All right. Hello, everyone. Welcome to today's Brown Bag. This is a presentation I gave at Star East 2017 called Using Docker to Enhance Your Testing, or Use Docker to Enhance Your Testing. And basically, this bit covers how Docker can affect testing in your CI/CD pipeline. So, quick overview is one, intro to what exactly is being affected and what we're showing. Two is a quick overview on Docker. Now, this presentation was created for Star East testers, so a lot of people aren't going to need this overview, but I'm going to go through it anyway. It's a good summary, and maybe you can use these slides to help with client if explain Docker to a client if you need to. Then we're going to dive right into how Docker changes testing, right? So this is basically what the effect of using containers is and how it affects what you're doing and your workflow and process and a whole bunch of other stuff. Next, we're going to cover the DevOps approach. And then lastly, we're going to go into a demonstration, and we're going to demonstrate how Docker physically impacts your CI/CD pipeline and things you can do to be more effective with it. And then we're going to show how we testers, since this was a test-oriented conference, testers can use Docker to more effectively talk to developers and speed up the feedback cycle for when there are flaws. And last, we'll go over some interactive questions. So, what is Docker? Docker is a popular form of containerization. There are other containerization technologies out there, but Docker seems to be one of the most popular ones. And containerization is a server virtualization method in which the kernel of an operating system allows the existence of multiple isolated user space instances instead of just one. So basically what you're doing is you're moving the entire operating system or an operating system into kind of a discrete unit that doesn't require all the heavyweight infrastructure of a virtual processor, and it allows you to more effectively multiplex what's going on the system. Other container technologies that are out there, there's BSD, has jails, so if you're familiar with FreeBSD at all. And for reference, I have the screen full size right now, so I can't see chat. If there are any questions, somebody just read them out to me. You can do a chroot. That's kind of like the poor man's quick and dirty containerization, where basically you change the root of the operating system to someplace else on the system. You have para-virtualized Zen, which is very, very similar to what Docker is doing. And then you have LXC and LXD, Linux containerization. And what is containerization versus virtualization? Well, virtualization allows many OS images to use the same hardware, where containerization allows many pieces of software to use the same OS in an isolated fashion. So the real big difference is the kernel. Basically, whereas a hypervisor for virtualization is this stripped down kernel that multiplexes the hardware, with containerization, you actually have an OS kernel, and it's gauging the interaction between everything else, and you can do some more complicated and more efficient sharing that way. So let's do a quick overview of Docker. Docker has three major components that, as a tester, you would be concerning yourself with. First are the images. The images are basically dormant dead container, right? It's what containers spawn from, and it's basically just the file system, all wrapped up neatly. The container itself is a running instance of an image, and you can spawn several containers from the same image. And as a matter of fact, that's what you do to get like identical nodes in a load balance cluster and stuff like that. And then you have registries, and registries are basically a repository of images. Docker Hub is a global public registry that you can register yourself with, so you don't have to stand up any of the infrastructure of a repository. There's always a local registry on almost any Docker instance that I've dealt with, and that's basically local to the file system or local to what you're dealing with, the machine that's running the Docker host itself. And then you can have third-party private registries, and we should all be familiar with Nexus. Nexus 3.0 provides a full-featured third-party repository. So are there any questions about how we're dividing this up, image, container, and registry? Okay. So with Docker, you also have this idea of a Docker host, and this is hardware and the OS that is shared among the containers. Docker service multiplexes the OS, it multiplexes the network interfaces, any devices, storage devices, and the Docker host itself can set CPU limits and I/O limits for each individual host, so no one container gets too greedy and bogs down all of the other containers. Docker, you can also bind hosts together to create a fabric or basically a virtual Docker host that's backed by more than one physical machine. And you have basically programs that will allow you to abstract out all of this so you don't have to do it manually. Docker Swarm is one of those, one of the ways of doing it. And this allows for high availability, scaling, and load balancing. So let's do a quick overview. Docker, the registries are highly based, Git-based, right? Docker push, Docker pull, Docker commit, this is all syntax that they borrowed from Git. The hashes, all things that they've borrowed for Git. So if you know a little bit of Git, that's going to help you navigate how the Docker registries are set up and how you can change and manage images. Second, there's this idea of promoting the container. So you might start with a blank container from CentOS or a blank container from RHEL or any one of a number of other distributions. And then in order to make the container useful to you, you're going to have to go through a process of customizing it, installing your software stack. This is normally handled through Dockerfile, but there might be some finer points. You might not want to have to generate the Docker file every single time or run the or do a Docker build every single time. So you can create points at which you can get everything the way you want it and commit those changes and create your own image so that you can move forward from there. And once you do that, you can do a tag and a push. You do a commit, a tag, and a push, and that will push it up into whatever registry you're using. And that will pretty much make it available for anyone who has access to that registry. There are a couple of different ideas about how to use Docker containers. One is that you use this idea of commit and push and publish to get the container exactly the way you want it. And then you promote that container and use that container verbatim in all the steps. But that means keeping everything almost exactly the same. Then you have this other idea of where you want to keep the guts of the container constant, but you want to change the configuration by mounting the configuration on different mount points. And this is very useful because then you can keep the same software stack with all the software at the same version, but you can mount the configs and the log directory on a per environment basis, and you can move the guts of the container forward to production. And then the things that are specific to the environment can stay on your highly available storage on those different mount points. And basically, this will make the container network agnostic, environment agnostic, and the thing that you're putting in production is the same thing you put in dev and test with only the configuration changes. And this can partially cut down on the amount of Chef code that you have to deal with. As a point of practice, I still use Chef because sometimes the Docker file language isn't expressive enough, and Chef is really good at managing all that change, but the Docker file can do a good set of things, and it can cut down on the complexity of your cookbooks. So what's the DevOps approach? Well, Docker file creation is one of the things that you're going to use. And basically, this is going to get your image to where you want it from a CentOS-based image or a RHEL-based image. You just have this list of commands that are going to be run, and one of those commands can be a chef converge. And then from there, you actually want to apply the same methodology that you use for software development to your container. You want quality tests for your container. So your container is going to have container unit tests. They're not strictly unit tests because you are actually testing the integration of a whole bunch of software within your container. But if you're defining the container as a unit, then it is. It gets a little, dicey there. But then you're also going to have your container integration tests using Docker Swarm, how your containers interact together, whether or not your app server is properly connecting to your database server, etc. And then you might have nightly testing and manual testing, and that's more for when you install the software in the containers. You don't just have the stack, you have the customized software, and then you're running your tests against that. And the whole point is that the reason you're using Dockerfile and Chef and all of these other tools is all of this assembly, all of this creation, and all of these quality gates are automatic. You want to automate 100% of the process so that when you have to stand up a new container, you press a button. You don't have to wait. And this is just a nice little graphic as to basically how you do that. And it shows the different, the different scales and the fact that you're continually moving through each one of those cycles. So once we have the software installed in the container, let's talk about how that's going to potentially change our CI/CD pipeline. You get the software in there, and then you start promoting the container with the software through some or all of the different stages automatically. So the first stage might be the dev stage, where you just see if the container can bring the software up into a running state. And this should have a very high level of test automation around it. So you're basically making a code commit. It's standing up a container, deploying your code to the container, seeing if the code has come up properly, and maybe running a rudimentary set of tests against it. So this way you know right away whether or not you have a candidate that should even bother going on to the testing environment where you might run your UI tests or a set of API level integration tests. Each quality gate should be automatic and triggered by changes in the Docker file or the underlying application. And so that's another thing that you want to affect your CI/CD pipeline. You want rebuilds to be done not just when the application code changes, but when there are Docker container changes. And so if you manage it in the Docker file, or if you manage as much of it as you can in the Docker file, you'll pick up the changes, you'll create your new image, you'll do rudimentary testing against that image, and so this way your container creation is going through as much scrutiny as your source code creation, your feature creation. And also, one of the things you want to do is you want to save your failures automatically. You want to preserve them for 24 to 72 hours. You don't want your storage space to get exponentially destroyed, so you do want some sort of aging out process unless you manually want to keep a failed image. But basically you want to have them around so that when you make a change and it takes 15 or 20 minutes to go through the pipeline, you can go back to it later after lunch and see what failed. Just throw in the number, see what failed, and you have all the state lying right there. So this demo at the conference was done interactively. I don't know how well it's going to translate. Hold on. I don't know how well this is going to translate, so bear with me. Basically, what we have is you get requirements, and those requirements going to cause the developers to build something, right? And let's just say the requirement was, I need a blue seal balancing on its flippers with an eye, okay? Well, this is what the developer made. You can see it's blue seal, it's balancing on its flippers, and it has an eye. So that's going to get passed off to the testers, which should have a more, or may in many cases, have a clearer understanding what the requirements should be. And they're going to start talking to the product owner, looking through the requirements. And they're going to realize that this is actually what the product owner wanted. You can see it's a seal, it has an eye, it's still standing on its flippers, but it's not quite what the developer delivered, right? And let's take a look at these issues. The shade of blue is wrong, the eye is on the wrong side. The objects are actually mirror images of each other, and the seal is balanced wrong. And here are some of the problems with the traditional approach to recording these deficiencies. I have to specifically articulate each issue. I had to go through, look at each issue, and write down. And there's always a little bit of, should I break this issue up? Should I write this down at one issue? And as I was having one of the people from the audience document these issues, I was timing them. I said, well, how long did it take you to document each one of these issues? And then one of the other things is that these issues don't really translate well into words sometimes. The shade of blue is wrong. You go to a developer with that, and they're like, well, it's blue. Isn't it blue enough? And the eye is on the wrong side. He says, yeah, but the requirement says it has an eye, and I did that. They're mirror images of each other. He's going to shrug his shoulder and say, well, what does that even mean? I mean, it's a seal, right? And so explaining why each one of these issues is really an issue also takes time. And after the person that I pulled out from the audience documented everything, we argued. And I took a total time, and I said, hey, look how long that took us. And it took a couple of minutes to go through all of those issues. And basically, what I did then is the following. I took the two items and I put them next to each other. And then as a developer, I picked them up and I said, it's positioned wrong. It looks like a mirror image of itself. Things are on the wrong side and it's the wrong color. And I said, by actually showing me what the product owner wanted, and by actually showing, being able to show me what was wrong, you were able to communicate much more quickly than as if you submitted 5 different bug reports and I had to traipse through each one of them and find the problem. So this is the difference between writing a whole bunch of bug reports against the application and being able to take the application and concisely show me what's wrong. So how do we speed up our feedback cycles using containerization? One is developers can have complete access to the containers to look at the logs. Failed containers can be preserved in a private registry, and they can be preserved statefully. And testers can then demo the defect on demand. Since we've invested in reliable containers that can be spun up quickly, the problem of reproducing system state is diminished. The tester can start their test case quickly by requesting a new environment, run through it quickly, and show it to the developer right away, and fail it potentially, and freeze it potentially right before the failure, and then bring it to the developer. So we look at the old way of doing things, and that was one of the things that was outlined in the demonstration. We find a bug, fight about it, compromise. Finally, the developer has an understanding of it, and then we fix it. And the compromise to fix it stage, that's being generous. Usually there's prioritization and backlog and a whole bunch of other things that take place. In the new way of doing it, the tester can find the bug, demonstrate it in a way that's concrete, and give the failed artifact over to the developer to look for ways to fix it. So now what I'm going to do is an actual demonstration of a pipeline and what this looks like inside a pipeline. Just for reference, this is a very simple architecture. It's Tomcat 9 talking to MariaDB. And Here we go. So what this is a clean build. We're going to do some test-driven development. And this is a clean build of the last application that passed, or the last version of the application that passed testing. And I wanted to show that. And now we're going to add a new feature. So since we're doing test-driven development, the first thing I'm going to do is write the test. So I'm going to go into the testing source code. These are the UI tests. And this is the 50 states demo. And in the 50 states, I want to add the U.S. Virgin Islands. And so I'm going to add USVI as the state. And I'm going to add the capital. And since I'm not a geography buff, that's Charlotte Amalie. I had to look it up. And now I have a UI test that shows me the feature that I want. And at this point, I'm going to run this through the pipeline because we're doing our tests first. And I'm going to speed that up a little bit. We do the commit, the push triggers the build. This has our initial array of testing. This has our unit tests. It has our build, our packaging. And what's happening here is we're following the philosophy of having a container that's constant and then using mount points to change the configuration and to change the software that it's looking at. And so here's our sonar scan. We'll package everything up. And we bring up the containers around the configuration and the software. And then we kick off a special Docker testing container. And we use XVFB to run all of our browser tests in that container as well. And we have, as we get through that, we're going to have our failure here in a second. We have our failure, one failure, the new test failed, and that's as expected, right? We're doing test-driven development. We started a new branch, a new feature branch. We created the test, and the failure causes a state capture here. That's what's happening now. It's capturing the failed containers, but we're going to ignore that because we knew it was going to fail. We're doing test-driven development, wrote the test, failed because we haven't created the feature yet. So then, now that that's done, as a developer, I'm going to go back into that branch, and I'm going to add the feature. So here we are. We're controlling the database with Flyway. So since the UI is database driven, I'm going to go into migrations. I should create an entirely new migration, but for the sake of speediness, I'm just going to add it to this query. And we're going to go in, and I'm going to put in USVI and Charlotte Emily, commit, and push. And now we're going to go through the same process. I'm going to do my unit tests. I'm going to do my packaging. I'm going to do my sonar, my static code analysis, my sonar scans. And then I'm going to run my tests again, and everything should be great. Except that it's not. The tests fail again. But I added the feature. I added USVI. You saw it in the source code. And it failed. Well, I don't understand why it failed. So I wait for the state capture again. And I catch the build number. And in this particular example, I'm controlling state by the build number in the CI/CD pipeline. So I'm going to spawn the failed instance, and I'm going to see what happened. And this takes the instance 90 that I created as I was doing my commit and my push, and I'm just going to replay it. So I throw in 90. The bad instances were stored in the Docker registry. It pulls them up again. The start script knows how to fire up all the services, and I'm going to go in and I'm going to see what's wrong. So I wait for them to start running. I grab the MySQL port and the Tomcat port. And then I go to the application. And there it is. And all the way at the bottom, I take a look, and I can see that USVI is not capitalized. And in the test, it's capitalized because that's part of the requirement. Abbreviation should be capitalized. So then I can go in, having seen what was wrong with my own eyes, fix the issue, push it, start the run again, and all my tests are now successful. And then we can take a look at the final status. We can ship it. All right. And so the interesting part here is using Docker, because Docker is so much more lightweight compared to having to deal with the whole VM. I'm able to reproduce the system, and I'm able to analyze the failed system quickly, rather than figure out what version was installed. And it's a perfect reproduction of the system, rather than have to figure out what version of the application was installed when, and possibly track down an issue that may have been masked by a configuration management issue, or may have been masked by somebody doing something that I didn't know about. And that's the other point. I have perfect configuration management. I've sent the entire system in the state it was when it was failed back to the developer for analysis. And the developer no longer has to do any of that third-party, hey, sysadmin, did you change something? Hey, storage admin, did we change something? Hey, database admin, did we change something? He can go in and he can look at the system as it was exactly and see why it failed. And that should cut down troubleshooting, analysis, and bug fixing times, closing the feedback cycle. So the operating system, because of what it was, used to be the domain of specialists due to the impact of one wrong change. If you're managing an entire operating system and you're having several different services run on top of it, one wrong change or one wrong configuration tweak could bring down all of those services and impact many people at once. Now, what Docker allows us to do is isolate those services, put them in the hands of the developer. Now, the host should still be maintained by those specialists, but something very nice happens. We put all of the change, all of the difference between the different servers in the developer hands, and the specialists can maintain uniform Docker hosts across the organization. The containers put barriers between the software stack and the OS. So that means unless something really strange is going on, what's happening in the container is going to be somewhat isolated and protected from the OS. We can also at this point allow the testers direct access to the containers in dev and test so that they can see logs, they can see what's going on. Maybe they have a bad test, right? They roll through the logs and they can see that they're testing for the wrong things, rather than having to put in a service desk request, wait 24 hours to get the log back and then forget what they were testing in the first place. Containers can now be tagged with test artifacts. The test case that failed, the code branch that failed, you can capture system state and get that in with the failure. So you don't have to read back what state the system was in on Tuesday when you ran the test. And testers can capture the failure state, which is more complete than just a description. When you give the developer, and the developers can start the container in the failed state to debug. You can now take the system in the failed state and throw a Java debugger on it and see what's going on and what happened and what went wrong. Or the tester can bring this container to the state it was in just before the failure, give it to the developer, and then they can attach the debugger to see what goes wrong. Why does this matter? CI/CD cannot work in a meaningful way without a quick way to pass information. Bug interpretation by the tester takes time. Version matching of the environments takes time. Developers understanding the issue takes time. And getting the application in the right state takes time. Docker can be used in such a way to considerably cut down the amount of time each one of these things takes. So following a CI/CD doctrine and using Docker can make you fail faster, and Docker can tell you why you failed faster. So since this was a testing conference, I was trying to get into what the direct effect of this was going to be on the testers. And one of those things is that you have a change in the bug report. So instead of creating a really complicated bug report, you can have a much simpler bug report that references the Docker container. And basically this is communicating your entire state in one line instead of just a whole bunch of descriptions. So you have the system version, the system state, logs, and a description of event. And 3 of those things are in the container, and basically what you're doing in your bug report is you just have the description of the event. So as a tester, what do I need to know? So since this was a testing conference and I'm introducing the testers to Docker, basically what I'm telling them is you need to have a high-level overview of how Docker functions so that you can adjust your test strategy accordingly. What a Docker commit does, not necessarily how to do one, the difference between an image and a container, what's a private repository, and why that's important. You don't want all your failures aired in public, especially if you're an organization that's doing something critical. And how you automate pushes to the private repository so you can capture all this state, or how to have somebody do it for you at a really high level. And as a tester, also how to change your defect reports to be more concise and to rely on the container. So how does this fit into Agile? Well, by reducing the testing feedback cycle, meaningful manual testing can now fit within sprints. A lot of organizations now basically lump all their manual testing together because it takes a long time to coordinate all those people, collect all the results. By partitioning off everything into small features and being able to communicate very quickly with the developers, you can isolate down what you have to do and communicate effectively using the container. A slight change to the story in the epic format. Your stories might now contain a user story if you're a tester, the test case, and the container ID, just to latch on what you're going through, or an image ID, so you have what you're working on. Sprint planning can demand certain features and branches be tested in a particular container for UAT. So say the container is frozen at this point because you've done all your software upgrades, and that can be one of the requirements. And you can use that to clearly set deployment expectations. And you can make that part of the definition of done. It must deploy and work on container X. And this is good because then you can bring that container up front into the developer's laptop or the developer's development environment, and you can bring that pane forward. You can bring all of that stuff forward so that developers can see it right away. So say you have a software upgrade. It's now baked into the container. The first thing, as part of the definition of done, first thing that it's in the developer's interest to do is pull that new container and see if all the code works. And you're doing that at the beginning of the sprint before anything starts, rather than throwing your code on an upgraded version of the OS much later. One of the things that I tried to talk to the people at the conference about was adaptation. So there are basically 3 ways that you can deal with this. 1, Docker is new and I don't have it. I view this as an opportunity. You can make testing be part of the Docker process because it is often overlooked. Upfront implementation is cheap, and you can now latch onto this and get your hands in it and make testing a first-class citizen when they're deciding to set up the Docker infrastructure. We have Docker, but they didn't think of testing when they implemented it. Well, show it with a private repository and show how you can do the state capture. It can be a cheap add for great gain. And then the last is we already do what you're doing. No, actually it's cooler. And in that case, I was using that as a wedge to get people to talk to me to see if anybody had implemented something like this system and basically what their thoughts were or how they did it. So in conclusion, as a tester, I don't need to know about copy on write file systems, orchestration, swarms, or any other advanced containerization topic, just the basic concepts. If my organization implements Docker, I should be able, as a tester, to get command line access to the container to get more information for my defect reports, software version, container version, log access. And this shouldn't be a big deal. I shouldn't have to fight with anyone and do this because it's a container. They're disposable. Using an image of a broken container is an extremely effective way of communicating and augmenting your defect tracking. Lastly, containers can allow me as a tester to communicate more information with developers effectively. And that is the end of the presentation. I'll now open the floor up for questions. Anyone?
Glenn?
Hey, Glenn.
Yes.
Hey, it's Jeff.
Hey, Jeff.
Hey, question for you. So I know this talk was oriented at testers. I'd love your thoughts on, I mean, if in your pipeline something fails, it could be a bunch of different things. Could be the code has a bug. Could be the test has a bug. Could be the chef script or whatever Docker stuff. What do you call it that you use?
Docker file.
Yeah, your Docker file could be screwed up. Do you advocate, it's one thing I've been thinking about, that when something fails in the pipeline, you have the DevOps team, which ideally would include someone from dev, someone from ops, someone from test, look at the failure, triage it, and then send it to the right person? Is that the MO when something in the pipe fails, ideally? Or if not, why?
Yes, actually it is. And one of the things that we have to support this is the container retention policy, so that we realize that it's a multidiscipline team and you might be doing all things at once. You can go back and look at the failures as time permits and then triage them and forward them on. And so yes, I would advocate that the DevOps team look at it and decide whether this is a container software stack problem, in which case the container needs to be reworked and you would send it to the ops guys, or whether or not this is a software problem where you would have the tester look at it, submit a defect report and send it to the developers, or whether it's a pipeline problem and oh shoot, we're pointing at the wrong registry, let me go run out and fix that. So yes, actually that is the method that I advocate.
And then each of those groups could have their own private, you called it a registry? What was it?
They could.
Or would you just use one and tag it by its failure mode, if it's a test problem or a dev problem? How would you do that, do you think?
I would say it depends heavily on volume, but for small to medium projects, I would say that you use one registry for dev and test and one registry for production. So this way, if you have a catastrophe and the pipeline accidentally drops a whole bunch of images, you don't affect production.
Right. And then do you, so you keep these images around if they fail? If they, well, I shouldn't say the image, right?
No, actually it is the image. You freeze the container and then you create an image from the container.
Oh, yeah.
So
Okay.
It's a failed image.
if it doesn't fail, you delete it, right? So you're only you're only freezing and keeping the image so you can basically, do root cause to figure out what happened with that container.
Right.
Otherwise you're not gonna waste the space and do the effort to image things.
That's correct. You're only keeping your own, so you're going to have one copy of a good container, and then everything else is going to be your failures. So it's going to be the container plus the state to the failure.
Cool. Thanks.
Glenn, this is Rich. Hey, just in general, did you get a lot of questions or follow-up, or how was this received by a by a tester crowd? Did they all look like deers in headlights?
No, actually, because I brought down, I worked really hard at bringing down what the basic concepts that they needed to understand were. And I focused on those concepts through the talk, and I actually got a lot of back and forth with the audience. It helped, too, that I actually had a very good audience. I had, I probably had 3/4 of the room filled, so I probably had about 40 people, 50 people. But talking to the testers, I just delved into the ideas of how does this affect my agile process? How does this affect my defect tracking? How does this affect my testing process in general? And they felt that they had a lot to talk about when I just addressed those issues.
Cool. Yeah, I'm thinking level of effort to kind of evolve into this. What I took away from you was that certainly being able to make your stuff run in a Docker container is certainly a bit of an effort, right? It takes it. That's usually the tricky part of trying to get that to all work. But after you get past that, it sounds like the items were basically, make sure you can run it in Docker through a Jenkins build. Do some maintenance to be able to keep hold of those Docker containers for some period of time, and then write the replay job so you can get it back up and functional when you need to debug. How difficult was it to get all that running, I guess?
So actually, the demo itself, so this, you have to understand, this came out of two pieces. I use this as a forcing function to do a lot of work for secure CI. So a lot of things that weren't directly related to this implementation. So I did actually spend about 2 or 3 months of my free time, which, to be fair, I don't have a lot of, so 2 or 3 months isn't actually a lot of time, getting the infrastructure ready for this. But once I rolled into the containerization part, once the Docker infrastructure was set up and the private registry was set up, it actually didn't take that long. There are two things that you need to consider that were really hard. One is figuring out a good strategy for your external mount points and how you're going to deliver the application to the container. And then the second part is basically keeping all of the containers orchestrated properly. And what I didn't use and should have used was Buckholz or Docker, basically Docker Compose, right? If I had done that, that would have been much easier. And I really only would have, the thing that really only would have taken me a long time would have been figuring out a strategy to get the external mount points and delivering the application. Actually wasn't all that bad once I had the infrastructure.
Cool. Thanks.
Hey, Glenn, this is Gene. Hey, I'm actually doing a workshop at SDPCon on Docker, the same one I did at Star Canada last year. So I'm probably going to steal a bunch of this because I like the way you did some of these things. But we should talk about trying to combine them into one bigger tutorial, because I think you went a different way than I did on it, but I think yours talks better to the testers than just showing off the demo. But nice job.
Yeah, and it'll be good too because I'm giving this talk at SDPCon.
Okay, that will be good.
So we can cross market and get all that built up.
Absolutely.
Wow, crickets. All right.
Hey, Glenn, it's Jeff again. So we have time, right?
Yeah.
So these are kind of a little off topic, but I'm kind of curious to get your perspective. So, you hear a lot of people say, well, one of the challenges with containers are, since they're sharing the kernel, the operating system, across different containers, right? Is that the right terminology?
No, across the same host. So
yeah.
you have a bunch of containers on the same physical host.
Yeah, isn't there a concern that problems in the operating system kernel might, allow security breaches between containers, and, doesn't that increase the security risk as compared to VMs? What's your view of that and sense of how important an issue that is, and is it a real concern, or is that just like FUD?
It is actually a real concern. So, but the only concern is if you have, if you follow a good security doctrine of isolating your tiers, the issue rears its head when you're sharing your infrastructure with other applications, right?
Mm-hmm.
So one solution is if you're having a high volume application, you just don't let anyone else use your Docker infrastructure. You just use it, and capacity is needed. And that's not far-fetched, especially if you're integrated into EC2, right? But that's another point. Amazon has integrated this infrastructure in EC2, in the EC2 container service. And so while it is a risk, it's a risk that's been accepted by most organizations already. And really the only problem comes is if you're sharing your host operating system with containers that aren't from your organization. And the question is, how likely is that going to happen? Does it increase your security exposure because now you have two different attack vectors, because you have two different applications exposed to the internet on a host? Yeah, sure, it's possible that a bad actor could compromise one container and then get to another, but there has to be some level of risk that you need to accept when you want to multiplex your hardware, and most people commercially have already accepted that risk.
Okay, thanks. How about the risk of malicious code being inserted into a container and propagated through your pipeline into production? So the security of your container itself, and the app inside of it. Any thoughts on that?
So Jeff, this is Gene. I don't think that's any different as far as getting the stuff in there than in any other type of architecture. On the other hand, the scanning tools and testing tools that are out there for full-blown images, or whether they're VMs or physical, don't always apply to containers. So it may be harder to scan for that type of thing, I think.
And I've seen like security monitors for containers popping up, like products that monitor, Docker images and other types of containers in your pipeline or in production to try to identify and, well, at least identify and notify you if there's anything that looks suspicious. So I assume that's one approach people are taking.
Yeah, I talked to a couple vendors last year at DevOps Days DC, and when I asked them kind of what they did security-wise, they said, "Oh, we do everything. We make it completely secure." Okay, how do you do that? Well, because it makes it completely secure. So I'm not quite sure how mature that area is yet.
Yeah, I mean, one thing is a lot of security tools are whether or not it's a container are somewhat agnostic. If you took the STIGs and you used SCAP to scan the image, you would get pretty similar results as if you scanned a VM. So some static analysis tools don't care, and you could just easily adapt to those. But in terms of other stuff like external scanning and penetration testing, there is a layer of complexity there that I just haven't delved into. Now, malicious code, I would say, is the same risk as if you're using any other virtual infrastructure, right? I mean, whether you're defending your container or you're defending your virtual
your
VM image,
Yeah,
and
same
it's
thing.
the same level. Yeah.
That makes sense.
I mean, the only difference is you could attack the registry, and that's an attack vector that, but even if you attack the registry, there's an analog in the virtual machine world. You have your VM library in vCenter or whatever. All right. I need to run. I have a client meeting coming up.
Thanks, Glenn.
If you guys need any, thanks. If you have any other questions, please let me know. This demo is going to be optionally part of Secure CI. So if you can stand Secure CI up using Test Kitchen. It's in the alpha stage right now, so we're still working out a few bugs, but we have successfully used it. And this demo was used to help teach a DevOps class given by Arjun. So people are actively starting to use it right now. The more we use it, the shinier it gets. So let me know if you actually want to get your hands around it, and I'll help you out. Thank you, everyone.
Thanks, Glenn.